anytime you hear the word total, it's an accumulation, right? That's what total means. You're adding things up, right? That usually means integral, okay? Integral. So integrals as net change. So things that change over time, how is it changing? Change is mostly derivatives, but as you guys see here, we're finding integrals of derivatives, right? Of derivatives. So that's where it comes from, okay? So it's another reason why it's a big a free response section is because it involves derivatives and integrals. Anytime you can combine those, that's 90% of what we do in this class is either derivatives or integrals or both. So that's why it's pretty big. Okay. Okay. So net accumulation. So net, anything net means gained, right? Gained. So like this has nothing to do with it, but if you're talking about like a business and you're talking about net gross versus revenue, revenue is what you bring in. I sold this much, whatever you sell. Okay. Net means after expenses. Okay. After expenses, this is how much I got. So profit, right? So anytime you have net, it means everything extra. Okay, so net accumulation on an interval. So the idea of is distance versus displacement. Okay, distance. So if you take 2 steps forward and 1 step back, how far total have you traveled? If you take 2 steps forward and then 1 step back, total steps. In other words, total steps. How many have you taken? 3 steps, right? Net, what is the total displacement? Displacement means net. So in other words, how far are you from where you started? If you took 2 steps forward, I'm 2 steps away from where I started, but then I took 1 step back. So how far am I from where I originally started? 1 step, right? So that's the difference. That's the difference, right? Okay, so here's some things here. Okay, so anytime we want to find displacement, so just the net change, just the net, we're going to integrate velocity. Okay, so integrate velocity. If they're looking for total distance traveled, how far did you travel in total? You're going to take the integral of speed, which is the absolute value, so only the positive version of it. Okay, so if you only have, if it's dt, right? So most of the time, we're going to live here in these 2 rows because the only time, when is the only time I'm going to need to change? So what's the way to say this? What's the independent variable? What's the independent variable here for any of these guys? Time, right? And time is never negative. So those brackets or those absolute value are kind of meaningless because we're always going to be plugging in positive values. Okay? New position. So new position. You got to take the old position. Where were you at to begin with? And then add in any change. Add in any change. Okay, so that's what that means. Okay? And then this is from your notes last semester. I took this out. I took this, kind of cut and pasted it because they're going to ask you about objects moving left, objects moving right, objects stopped. What does that mean? Right there. Okay, so it's a little bit of review. So it's kind of a, it's kind of a, just kind of reference. Okay, so here we go. Example 2. Suppose the velocity of a particle moving along the x-axis, so it's only moving left and right, is given by velocity. So velocity v of t. When time is 0 to 2. So when is the particle moving to the right, and when is the particle moving to the left, and when is it stopped? So when do we know if a particle is moving or an object is moving to the left or right? What tells us that?
If v of t is positive or negative.
Velocity, right? If velocity is positive, it's going to be moving to the right. If velocity is negative, it's moving to the left. If velocity is 0, it's not going anywhere. Okay, so we need to figure out where that's true. Okay, so velocity, let's see, moving to the right. V of t is positive. Moving to the left, V of t is negative. Stopped. So that's kind of review from last semester when we talked about this. So moving to the right, how do I figure out where V of t is positive or where V of t is negative or where V of t is 0? What do I need to do? I have V of t, so I have it. They told me, so I don't need to figure it out. It's 6t squared minus 18t plus 12. So where do I start when I'm trying to figure out where it's positive, where velocity is positive, negative, or 0? First derivative test, right? So normally we'd find the first derivative, but they already gave it to us. So we don't have to find the first derivative. Okay, what's the second step after finding the first derivative? Set it equal to 0. Okay, so let's set that equal to 0. It's a trinomial. So for a trinomial, let's see, the GCF, I can divide them all by 6. So you get t squared minus 3t plus 2 equals 0. So we're looking for two numbers that multiply to be 2 and add to be negative 3. G and t. What two numbers multiply to be positive 2 but add to be negative 3? Negative 2 and negative 1. So velocity is 0 when time equals what?
2 or 1.
2 or 1. And they're both positive, so they're both within the interval, right? So we're good there. So these guys is when we say the object stopped, right? Or the particle or whatever it is stopped. That's when V of t is equal to 0. That's part of our answer. So then after we did that, how did we do the first derivative test? What did we do next for the first derivative test? Make a line, right? The number line. And then we place the two critical values on there, right? So I'm going to stop. It's not going to be a line. It's going to be a ray because I can't go negative. So this is 0. Can't go left of 0. So I got a 1. I got a 2. So then I'm going to plug in numbers in between 0 and 1, plug in numbers in between 1 and 2. And actually, you know what? It doesn't even need to be a line. It could just be a segment because look at the interval. The interval stops at 2, right? So I just need to take a look to see if in between, I don't have to go greater than 2. Because anything that happens greater than 2 is not going to help me because it's not in the interval. Okay, so pick a value between 0 and 1, 0.5, 0.2, 0.3, whatever you want to do. And then pick a value that's bigger or in between 1 and 2. 1.5, 1.1, whatever you want. And you can use your calculators. Plus 12. So again, we don't care necessarily what the value is. All I care about is it positive or negative? That'll tell me if the object is moving right or moving left. So when you plug in 0.5, what do you get? We get a positive number, right? We get a positive number. And then plug in 1.5. What'd you get when you plugged in 1.5? Negative number, yeah. Okay. So what does that tell us? That tells us that v of t was positive from 0 to 1, means it moves right. So object moved right. It moved right from 0 to 1. When did the object moved left? From 1 to 2. And then we said over here where the object stop at 1 to 2. Okay. So that's review of what we did last semester, because a lot of that lingo you're going to see today. You're definitely going to see object moves right, object moves left, v of t, you're going to see all those types of things. Okay? So now let's get to today's stuff. Turn it to the next one. So we're not quite done with the problem yet. We got part B. So remember, the interval is from 0 to 2. From 0 to 2. Okay, so that says find the particle's displacement. That word looks familiar. Over the time interval. So how do I find displacement? What did it say to do to find displacement?
How far from the starting point?
Okay. So how far from the starting point? What did it say?
Integral of velocity.
There you go, integral of velocity, right? Displacement is integral of velocity. Okay, I have velocity, and I think this is the first time we're going to do an integral on our calculators. I'll show you how to do the integrals. Okay, so let me write this down. Displacement, since this is our notes, let's write some note stuff, equals. Okay, so displacement is going to equal 0 to 2 v of t. So since they've already established what v of t is, you don't have to write 6t squared minus 18t plus 12, especially because we're going to use our calculators. Okay, you could just write that. Okay, so I'll show you where all the calculus stuff is on our calculators. So here we go, calculators. Okay, so go to the calculation, obviously. Okay, so now what I'm going to do is, on the keypad, there's no calculation stuff, so we got to find it. Any type you want to find something, more than likely it's going to be in the toolbox. The toolbox is right between the copy and the clear. It's where it says paste. Directly underneath, okay. That is the toolbox. Toolbox has all the functions. It's kind of the function button. It's got a lot of hidden under there. So we're going to go down to calculus, hit enter. The first two are derivatives. We don't want derivatives. I want an integral from a to b with a function in there. So I'm going to hit enter for that one, and it's going to give us the setup. So here we have to actually type in 6t squared. You don't have to use the t, you could use the variable. So we'll go 0 to 2. V of t, so 6, the variable button is just right underneath the black power button where it says cut x n t. That's the variable button. Okay? Squared plus, or sorry, minus 18, and then plus 12. Already got a dx there, right? Hit enter. There you go, 4. The area under the curve from 0 to 2 is positive 4. Okay. We've done that problem a lot by hand. You could still do it by hand. It's an easier problem, right? You don't have to do U substitution. But since we have calculators, since this is a calculator okay section, just use that. Okay. Next one. Find the particle's total distance covered. Total distance covered. I remember seeing that as well. Total distance traveled. What did it say? How do I find total distance traveled? The integral of speed, which is the same thing as absolute value velocity.
That's not the
Okay.
entire thing.
So it's going to be the same. It's going to start out the same, 0 to 2, except we want velocity absolute value. So in other words, this is what we're going to put in our calculator, except without the t's. Absolute value is in the same toolbox. So if you want absolute value, you go to the same toolbox that you found the integral. So we go to the toolbox, integral, 0 to 2. Go over here. Now I want a absolute value bars. I want absolute value. So then I'm going to go back to the toolbox. You're going to go back to the toolbox. I'm in the calculus toolbox right now. I want to get out of that to go back to the original. So you just go back. Go back up to absolute value. And there are your absolute value bars. 6x squared minus 18x plus 12.
Since I go from total
Okay.
distance. Total distance without using absolute.
6, which is 6. It's different. So the total distance was 6. The displacement was 4. So what does that tell you?
Appears to have taken, wait a minute.
They went back somewhere.
Went back somewhere.
So someone
Doubled back somewhere. Right? It wasn't a straight path. It doubled back somewhere. Okay? All right.
he took 5 steps forward, 1 step back. Thinking about it.
Okay. Okay, so now we're going to set up an integral to find the particle's total distance. We know the answer is 6 without using absolute value. Without using absolute value. So don't worry about integral. Let's talk about steps. 2 steps forward, 1 step back, right? The difference between 3 steps total, right?
And 1 step.
1 step displacement. How do we get the total using well, first of all, do we know where it doubled back? Or do we know where it went in the opposite direction?
No. Wait.
We actually
No,
do.
no, we do.
We do, right?
Yeah, we do.
Oh, we do.
Yeah, we actually do, right? So it's moving to the right from 0 to 1, right? And then it doubled back. Did it go all the way back? No. No, but it doubled back, right? So if I want to find the total distance, I'm going to take the positive region, right? And then what am I going to do? Not add it, or kind of adding it. You're adding what are you adding? So if we're going positive this way, right? So if I added it and made them both positive and added it, that's exactly what I just did. They don't want me to do that because that's all positive, right? The easy way is just to say make both of those positive and add them together. That's what I just did. So I want to do it without doing that. So if I go 2 steps, so if I take forward and then go back, you're adding them together, but what are you adding? The right. Well, we don't want to use absolute value. We're not allowed to use absolute value for this one. So you're adding the right. I went right however many till I got to 1, and then I went back, right? So what would I do instead of absolute value? So the way I did it for C was I just said make them both positive, add them together.
From 0 to 1, minus 1 plus or minus from 1 to 2.
Yes, so you're getting there. So let's say we went, so from 0 to 1, I don't know how much I went, right?
Mm-hmm.
That's positive. That's a positive number. Let's see, let me write this down. So from 0 to 1, I did a positive.
Mm-hmm.
Right? And then I went negative, right?
Yeah.
So a negative number. If I added them together, what would I really be doing? Subtracting them. That's not what I want to do, right?
Yeah.
So if I want to add them together, what needs to go there? A minus. Then aren't I really adding them together?
Yeah.
That's what I want to do. I want to take the first part of the integral, and then subtract the other one because I know I'm going to get a negative number there. And then if I add those together, that'll both give me, and we're going to check it out. We're going to check it out too. We're going to verify to make sure it's not. So the first one was from 0 to 1. Minus 18t plus 12.
Oh, we actually haven't read it.
Okay? Yeah, it says,
Oh yeah, we gotta actually.
yeah.
We actually gotta set it up.
We don't have to solve it. We know the answer. It's going to be 6. And then we don't want to add because I know the next part's going to be negative, right? Because if I put plus, that would actually subtract it. So the next part of the trip was from 1 to 2. I don't want to put a plus, like I just said, I don't want to put a plus there because if I put a plus there, you're adding a positive with a negative, you're really subtracting. I don't want to do that. I want to actually add them together. So to do that, that's where we get a minus from. Okay? So if you were to actually do that, watch, I'll do it real quick. I'll do it real quick on the calculator to show you. The nice thing about these calculators is you can cut and paste as long as your calculator remembers what you just did. My calculator doesn't remember. But you could actually verify it. You could go, watch. 0 to 1. 6x squared minus 18x plus 12. And then I minus.
How does yours not work? Mine worked just fine.
What did you do?
Nothing different.
No,
Look at
no.
it. Why? You don't need to put parentheses.
X plus 12. So if you actually do that and hit enter, you should get 6. Nope, syntax error. What did I do? Let's see.
Wait, I think
Oh,
I know you.
it's all
Your
the same
derivative of
root.
the entire thing.
Hmm?
Your integral is so.
I see what you're saying.
The entire thing.
Yeah, I see what you're saying. Okay, yeah. Yeah, it was the integral of the, well, yeah, it was more than I wanted to do. Okay.
This is why you.
Okay. So we get 6. Those of you that did it correctly, you guys saw you got 6. Okay. Even though we didn't need to find the answer, we verified that it's true. Okay. Okay, so now we're going to move to rates of change. You're going to see a lot of rates of change. The rate of change of this, the rate of change of that. That's really the same thing as velocity, right? It's really the same thing. Okay, so we're going to essentially use the same thing. And instead of distance, it's an amount. Okay, so they're going to be using that. Okay, so number 3. The tide removes sand from Sandy Point Beach at a rate.
Modeled by the function.
Okay, modeled by the function r. Okay, A pumping station adds sand to the beach at a rate modeled by the function S. So that's what R and S are. R is a rate of sand being taken away from the why does sand disappear from the beach? How is it, what's that process called? Not decay. What is making the sand go away? Is the sand evaporating, or what's happening to the sand? Why is the beach losing sand? The tide pulls in, right? Rip curl, right? The tide pulls things in. It comes in and then it pulls back, right? Whatever's in its way. That's sand, right? So sand is being removed. It's not disappearing, it's just going out into the ocean, okay? Well, a pumping station, this beach knows it. Sandy Point Beach knows this is happening. So they want to add more sand onto the beach so there's places to sit and to lay and to, it's probably a tourist spot, okay? So both R and T have units of cubic yards, and T is measured from 0 to 6. At time 0, the beach contains 2,500 cubic yards, and it's a calculator question. Okay? This is the part most people, if I didn't stop here, most people would have just said, not even been aware of that part right there that I just highlighted. Why is that important?
That's the initial value.
It's the initial value. It's what we started with. Because I've had students do this. They've calculated and they get it right. And I'm like, yeah, that's what changed. But what was the total? Okay? It seems pretty obvious, but I'm telling you right now. So on, not this last one, but this last group test, there was a question where you guys found area under the curve. Everybody found area under the curve perfectly, but you all got the question wrong. And why was the question wrong? Because there was an initial amount. It said there was an initial amount, but you guys we hadn't done this part yet. So that's the question I didn't count against you guys. That was the question I didn't count against anyone. Because, yeah, it was a question on the last group test. Why did I count that question? Because there was an initial amount and nobody answered that. Nobody considered that. You guys just calculated area under the curve. You guys did it fine. There was nothing wrong with it, but that's why. Okay?
I did that.
Okay? So here we go. How much sand will the tide remove from the beach? All right, we got to lock in now, okay? Because this, I'm telling you right now, that you're going to be seeing a lot of this type of question, okay? This type of question. And it's important to understand the word, what are they asking for? Because there's a lot of things, right? How much sand will the tide remove from the beach during the 6-hour period? Okay? And then indicate units of measure. So what are they asking for? Okay, so what does that mean? How am I going to, that doesn't really help me do the problem. Like I'm asking,
The original 2,500.
that's going to come into account, right?
How much of that sand is going to be gone by the end of the 6 hours?
Okay, gone. Gone is part of it, right? Yeah, okay, so yeah, removed. So out of that 2,500 that was already there, right? How much of it was removed? Which part did I forget? Which part of the process did I forget? Yeah, there's going to be more on there, right? So you can't just take 2,500 and subtract all that was left, right? Because there's also some coming in at the same time. So there's 3 things happening. There's sand already there. There's pumping station pumping in more sand. But then there's also some leaving. Okay? So there's 3 things that we need to take note of. Okay? So what they're asking for, here's the thing. Everyone can read this question and understand what they're asking. But how does it help me solve? Right? Oh, they just want to know how much sand is left or how much sand will be gone, right? Okay, then how do you do it then?
2,500 minus R of T plus S of T.
There you go, right? That's what we're going to do. That can help me, right? So we go back to the front. The biggest question I have is, Mr. Flores, it doesn't say total amount anywhere. I'm like, yeah, it does. Distance traveled, isn't that a total?
Yeah.
Right? old position plus the change in position. That's a total, right? So there's totals everywhere here. They just don't use the exact lingo. So just like I said, it's understanding what they want you to do, okay? Because if you can understand it conceptually, it's very easy. But getting there is hard. Getting there is hard, okay? Okay. So all they want to know is removed, right? So all they want to know is removed. How much is removed? Okay. How do I use a rate to figure out the total amount? And if you're not looking at the board, I have no idea. I can't make it any easier. I used about 5 words and 3 of them are on the board.
That's great.
So how do I find a total amount? Integrate the rate. Integrate the rate, right? Okay. So let's read the question and see exactly what they want us to integrate. Because we want to make sure we got this. We got a rate of R removed, right? We have a pumping station that's adding, that's S. And then we have sand that was already there. Okay, so let's start with the sand that's already there. Do they care, or do we care, about how much sand was already there?
Yes. Well, there's no rate there.
Where, no, I'm saying in the question. In that question, do we care? Is that gonna affect our answer, how much sand was already there?
Depends if it's higher than 2,500.
All right, we'll get to that later, right? We'll get to that later, right? But right now, I'm talking about, to solve this question, do I care how much sand was already there? No, I could care less, right? All I care about is what? All I care about is what?
Then you care about it.
Yeah, then you get
What's the only thing I care about to answer this question?
our rates. Wait, no.
I have 2 rates.
RT and
R of t, that's all I care about. R of t, that's all I care about, all right? All I care about is removal of sand, okay? So that is my rate here, stay with me, okay? That's my rate. So the total amount removed is going to be total amount removed,
I'm gonna get better for that.
It's already removed.
okay? Is the integral
Like big Y.
for the rate, which is R of t. What am I missing?
Our bounds.
Okay, what are our bounds?
0 and 6.
0 to 6. Okay, go to your calculators and tell me what you're going to get.
All right, so
Go 3 decimal places. If you get a decimal, go 3 decimal places.
0, 6. That is 2 plus 5. Sine 4 pi x divided by 25. Wait, no, cool. Oh, wow. I did the same thing. ID. Say what? No, because this is, wait, yeah, wait, yeah. Alright, cool.
Oh, no, it's just yours cubed. It's not power because it's.
Yeah, it's
So-
just zeroing.
31.186. Hopefully you calculated that. What's a unit of measure?
Yards. Cubic yards.
Cubic yards, right? So cubic yards.
No, because it's already says 6 hours.
Yeah, no, I see.
How the heck did you get 12?
What?
Wait, what?
They have the
We do
exact
the
same.
same thing.
Why is it different? Nothing changed. Bunch of degrees.
Oh, and the
Oh.
YT, total number.
Oh, yeah. Sorry, guys, I didn't even mention that. It should. You need to be in radians. Yeah, you need to be in radians for this
So
guy.
confused. I got 12.
Yeah.
How did you get
Are we-
31?
Oh, we're already in reds.
Yeah.
Already in
So
radians.
just I forgot to mention at the beginning. Yeah, make sure you're in radians instead of degrees, or else it won't work.
Everyone's already in radians before.
Okay. All right. So now let's go to the next one. Write an expression they don't want. So now they don't even want
An answer.
Oh, I had to-
an actual answer, right? They want you just to set up one because we're going to be using it later. Okay, so we will get an answer, but not yet, just for B. So they're kind of scaffolding it. They're going slowly for us. So write an expression, so y of t.
It's total number of cubic. If it's 0, it was that. Am I wrong?
Okay. The total number, again, so we got a total number. So anytime you see the word total, you should be thinking an integral of something. Okay? It's not a rate, it's a total. For yards of cubic sand on the beach at time whatever. So if they said, because they're going to say this on not the next question, but maybe the question afterwards. How much sand is at the beach at a given time?
Yeah.
So 1 hour in, how much sand is on the beach? 2 hours in, how much sand is on the beach? 3.5 hours in, how much sand is on the beach? What do we have to take into account there? I know I'm going to be doing an integral, but an integral of what?
How much is being removed and how much is being added?
Okay, so how much is being removed? You have to take that into account, right? Because that's going. How much is being added, right? You got to take that into account. And then the initial amount, okay? So the old position, in other words, the old position was 2,500. I don't need to find an integral of that because that's just what they told me. They told me the total amount that was there at the beginning was 2,500. Then I have to find the integral, the total, right, for sand that left, right, which is R of t. And then I have to find the integral of sand that was added, right? And then what am I going to do with those two? Find the difference, right? Find the difference. I need to subtract the amount of sand that was added from the amount of sand that left. Okay? In subtraction, it matters which one goes first. Order matters, right? So which one's going to come first? The rate that it's leaving, or sorry, the amount that left, or the amount that is getting pumped in? Which one's going to... Yeah, we're going to do added minus removed. Added minus removed. You could do the opposite. You would just get the opposite sign, right? So you could go removed minus added, but your number might be negative, and if you did it reverse, your number would be the same, but just positive. Does that make sense? Okay? So you could do both ways. You just got to take into account that my number is negative. What does that mean? Well, that means the second number that you subtracted was bigger, right? So you can do it two ways. However you interpret it will be a little different, okay? So if we're going to say S of t minus R of t dt. So if I get a negative number here, what does that tell me?
More is being removed.
More is being removed. More was removed than was added. If I get a positive, it's the reverse. Okay? That looks like an expression. What am I missing?
Bounds.
The bounds. What are the bounds?
106.
No. 0 to t. Yeah. 0 to t. Whatever time I can plug in. Okay? All right. So let's go to the next one. Which words are the most important on, let's underline, highlight, circle the most important things on this one, because doing that and making sense of it will make your job easier, make your job a lot easier. Okay, so what are the buzzwords? What are the important words here? Total amount of sand on the beach. Sand on the beach, right? Okay, that's important, definitely.
Not necessarily
What
the
else
T
is important?
T is 4. T
T is 4, that's important. What else?
rate.
This is the word I would have started with because that is what you're doing. I need to find the rate, right? Okay? So what do we know about rates? Rates are first derivatives, right?
Yeah.
Okay. First derivatives of what? So this is first derivative, right? Okay. Derivative of the total amount of sand on the beach. Does that sound familiar? That's y, right? Isn't that y? So what they're asking you to do is just find y prime at 4. Y prime at 4. That's all they're asking you to do. So before we go on, because I know once you get the answer, you want to move on to the next step. I know that, but trust me, with this, it's very, very important that you kind of understand why we did it and what it means, okay? So rate is another word for derivative. Derivative is another word for rate. So it said find the derivative at which the total amount, we just said that's y of t, right? Yeah. We just created that y of t. Is changing. Why is it changing? Because it's a rate at time 4. So that's why we got y prime of 4. Okay? So now let's go back. We don't have y prime though, right? We don't have y prime. So maybe we should start with y prime. What is y prime before we plug in 4 anywhere? What is y prime of t going to look like? Okay. So what would y of t look like? So help me out here. 0. Where does that 0 come from? The derivative of 2,500. It's a constant, so it's 0. Okay. So keep going. S of t, good. S of t minus r of t, with no more dt because you just found the derivative. So that's y prime of t. Now we can plug in 4. S of 4 minus r of 4. So now go to your calculator, plug in S of 4, plug in r of 4, subtract them. What do you get? Make sure you can do this on the calculator because on test day, Mr. Flores, I don't know where this button is. Well, did you practice? Right? So I'm giving you this time to practice on the calculator so I can help you. But if you don't practice and calculator day comes and I don't know where this button is. Okay? So verify you get negative 1.909 and change. So it's negative. What does that mean?
It's going down. Or more is being removed.
Yeah, more is being removed, right? The amount the rate that was being removed is higher than the rate that was being added. Okay? Slightly, not too much. It's almost 0. What units, measure of units? It's rate, so it's going to be over time, right?
Cubic yards per hour.
So we're still dealing with cubic yards, right? So cubic yards. And then the time is hours, right? We said hours?
Yeah. So actually not a lot.
Yeah, so it's pretty much even. It's pretty much even. The amount leaving is the amount that's the rate. Yeah, so it's the tide is taking a little bit more than the pumping station is
I
pumping.
mean, eventually the pumping station will lose.
Okay. All right, letter D.
Man,
Now we see some more buzzwords that we've seen. We definitely saw last semester and we saw last week as well. What are the buzzwords here?
minimum.
Minimum.
And value.
Minimum value.
How fun. Buzzword. Just
What
like-
other words, phrases that we should probably underline that'll help us solve?
Justify your answer.
No.
The 0 T.
0 is too silly.
That's important too, but I wasn't looking at that. Amount, right? This is a total,
Why do we miss that?
right? This is a total.
Justify.
Okay, we kind of know that one, y of t. Isn't that y of t?
Yeah.
Okay. Okay. So they want us to find at what time is y of t a minimum, has a minimum. Where does y of t have a minimum? So when you saw the word minimum, what did it go with?
First derivative.
First derivative, right? So we need the first derivative of the total, which is also called y prime of t, right? So let's write this down. Y prime of t we said was 0, and then it was s of t minus r of t, right?
Yes.
And then, so it says a minimum, right? So anytime it says a maximum or a minimum, but it doesn't give the word relative in front, it means an absolute. Okay, it means an absolute. So this means, because sometimes they'll do that. They'll say a minimum, and then, it's kind of confusing. What does it mean? Absolute or relative? It means absolute. Okay? All right. So what did we do after we found the derivative? If I wanted to find an absolute minimum or absolute maximum, what did I do after I got the first derivative? Got the first derivative, what do I do?
Find the 0.
Find the 0, right? Set it equal to 0.
Oh, yes. 0 equals 0.
Where is s of t minus r of t going to be 0? What does that mean? What does that mean? They're the same. Yeah, when are s of t and r of t going to be the same? How do I do that? What would the easiest way to be? What would the easiest thing I could use to look at it?
Set them equal, or basically.
Set them equal to each other, right? That would be okay, except they're pretty ugly functions, right? They're pretty ugly functions. So I don't personally want to do it, but my calculator can do it. So what could I ask my calculator? How would my calculator figure out where they're equal to each other? By using starts with a G, graph, right? Where do the two functions cross? Where do they intersect, right? If it was like a linear, if it was two linears or two, cubics or quadratics, go for it. We could do that by hand. But this one's a little crazy, so let's have the calculator do it, okay? So let's go. I'm going to show you how to do that. I'm going to show you how to graph. We haven't done graphing yet on the calculator, okay? It's not hard, yeah, it's not hard, but I got to show you where all the buttons are. So go to Grapher. So we'll put s of t first. S of t is, hit enter.
What is it? Why do we get the
15x over 1 plus 3x, that's one of them. And then the one right underneath that is r of t, which is 2 plus 5 sine 4 pi t over 25. Got my two functions. One's red, one's blue. Okay, so I'm going to show you how, on this calculator, I'm going to show you how to find where they intersect, right? We want to graph. So you're going to go up to where it says graph.
I don't know why this. I don't know why they're so zoomed out.
Okay. To zoom in, you put the plus. To hit the plus button. To zoom out, you hit the negative. Okay. Zoom in plus, zoom out negative.
I have the audacity to zoom in up to like -2.
Okay.
So far out.
All right. So here we go. You're going to go to where it says calculate. I want to calculate intersections. So you go up to calculate.
No one's worried.
And you're going to say, which one do you want? Pick any one. Pick any of them. Pick any of them.
-19.
And then you're going to go down to find. I want you to find something for me. Point of intersection. Point of intersection. And then you go back to your graph, and you're going to use your cursor to go left and right, and it will hit only the points of intersection. So right now, the point of intersection is -23.68. Y is 5.017. Okay? If I scroll to the left or scroll to the right, it'll always hit the... So do I want to write down all 1, 2, 3, 4, 5, 6, 7, 8? Oops. Hopefully you remembered my graph.
So far out.
No, just 0 to 6.
Yeah, just 0 to 6 on the x-axis, right?
Well, I would love to get there.
Mine is -.
Okay. So 0 to 6.
194,000.
Here's one of them right there.
I'm gonna look at this one.
5.117865, comma 4.6942, 694257. Okay, there's 1 point. I'm going to go to the right one more time. The next one is 13, x is 13 point something. That's too far. So there's only 1 point of intersection from 0 to 6.
That's
Okay.
those are numbers.
So let's go back to our graph, or sorry, to our question. Okay, whoa, we only got 1 minute. So we'll stop right there. Just write down, this is the point of intersection. Write down, this is the point of intersection, right? And then and then we'll finish up this problem on Monday. Okay? That was the point of intersection.